Welcome to the channel. So today we are going to discuss about implementing MCP primitives using Java and Spring Boot. And this is the last session of the three-part series. As I promised, during this we will talk about implementing the three primitives, tools, resources, and prompts. So again, I'm not going to take real-world use case here because it will be too complex and too much of clutter during the explanation of how to implement the primitive. So I will take some simple examples which is good enough to explain the concepts behind implementing the three primitives. Let's jump into the code. This is the MCP server setup that we did during the second session. I did one change here. The only change I did here is I split the application YAML file into two different YAML files. The first one is the local, which contains only the properties required for running the MCP server as a local MCP server. And the second one is the remote, which contains only the properties required to run the MCP server as a remote MCP server. So this way we don't need to mix up the different set of properties in one single file, and we don't need to comment out and do some arrangement during running before building. So this way we can use Spring profiles and we can say the profile is local if we want to run it as a local, and Spring profile we can set to remote if we want to switch our MCP server to a remotely running MCP server. So that's the only change. I'll share the GitHub link and you can find the details if you need. Okay, so now let's see how we can implement the three primitives, tools, resources, and prompts. So in order to implement any primitive with the Java Spring Boot framework, it's a two-step process. The first step is we need to do the bare minimum to plug in the tool or the resource or the prompt into the framework. So that's the first thing we need to do. That means we need to plug our component or the primitive into the framework so that the framework can digest it and make it available during the runtime. That's the first step. Once we successfully plug in our primitive into the Spring Boot MCP framework, then we can enhance it to make it more elegant. So we will start with the first step. We will see what bare minimum we need to do to plug in our primitives into the Spring Boot framework. I will start with the tool. So let's implement a tool. So what you need to do as the bare minimum to plug in a tool into the framework, first you need to introduce a Java class and tag it as a Spring Boot service or a component, and you need to implement a method inside and annotate it using the tool annotation. That's the first thing we need to do. Let's do it now. Okay, so let's introduce a Java class. Yeah, I'm going to the tool I'm going to introduce is a local file reader service. So I will name the class as a local file reader. So that's my file, and as I said, we need to annotate this as a Spring service or a component. I will component. So that's the first thing, and then we need to introduce a method here now, something like a read file service. Yeah, so I'll take the suggestion as it is. So this will be implemented, but we need to annotate this method with the add tool parameter. So add tool annotation. So, and we'll take the suggestion as it is. And so this is I'll say read underscore local file. Yeah, so this is the first step. So now once we completed the first step, the second step, in order to plug in the tool into the framework, we need to do another task. So what's the next task we need to do is we need to register the tool we need in the main application class as a bean. So to do that, we need to introduce a method here, public, and I'll say a tool callback provider. That's the tool callback provider, and I'll say register tools, and I'll come here and return method tool call back provider build, and no, not this one. I need to say dot to tool objects and this and build. Yeah, so this is, and then we need to pass our tool class as a parameter here, local file reader, local file reader. Yeah, so that's what we need to do. And this, okay, so this is the method we need to introduce, and we'll import this. And since we need to register this as a bean, we need to put the bean annotation here. So it looks like it's not imported. We'll import it. Yeah, so this is what we need to do. We'll remove this unnecessary import. Yeah, so and we'll save all. So this is the bare minimum we need to do to plug in a tool into the Spring Boot MCP framework. So once we do this, so now we are kind of ready with our tool. So then the next step, we can enhance it, but before going there, we will try this out. So I hope you understand what I did here. So the first thing is we introduce a class which functioning as the tooling class. So we always need to annotate that as a Spring component or a service, so that this class is discovered. This class can be discovered by the Spring DI container, and then we need to introduce a method. This is the actual method which is going to be called by the AI. So therefore we need to put this tool annotation here. So this tool annotation is coming from Spring AI package. So that needs to be annotated with a tool param, and you need to give a name for the tool. So this is the name that is going to be available as the available to the AI as the tool. And then we did some implementation here. So just reading a file based on the path given, it will read the file as a string and return the contents as a string. That is what we did. And if there is an exception, so we will print the exception and return null. That's what we did. And then once the tooling class is implemented this way, the only other thing we need to complete to plug in the tool into the framework is we need to go to the main application class, and we need to define this method, the tool callback provider method, and we can give any name to this method. It is not a standard, but we need to implement this way. And we need to provide our tooling class as a parameter here, and we need to use this method tool callback provider builder and tools objects, and we need to pass this object here and build it and return, and we need to register that as a bean. So then that way our tool will be discovered outside. So that is the bare minimum we need to do. So now we save everything. Now what we need to do is let's build this, and let's try running this MCP server as a local MCP server, and let's see using the MCP inspector whether this tool can be discovered and can be invoked. Right, so let's open a terminal and let's build this dot slash gradle w clean build. Now the building is all good. Now let's start the MCP inspector, and let's see whether this tool can be discovered on the MCP inspector. Let's open a new terminal, and we need to go to the build libs, because that is where we have the built jar files. And I'm going to run the MCP inspector from here, because the inspector need to access these files. Okay, npx at model context protocol protocol, yep, slash inspector. And that's the command we need to run. Okay, let's run, and let's see whether whether it's open. Yeah, it's open. I'll grab it here. Yep. So you can see that the inspector is there now. Now let's it's a local MCP server. So ST standard output, input output, and the Java is the command, and this is the arguments we need to provide as we discussed last time. But one additional argument we need to provide here. So that is the Spring profile, as I explained, introducing at the start of the session. Because since this is a local MCP server, the profile, active profile, must be the local one. So I will provide this command in the description below. You can find those, and let's hit connect and see whether we can successfully connect to the start the local MCP server and connect to it. All good. So it's started, no errors in the background, and successfully connected. So now we need to find out the tools. So this is resources prompts tools. So we click on the tools tab, and okay, I'll maximize this so you can see easily. So, and what we can do is we can click on this list tools to see whether it discovers the tool that we introduced to the framework. So let's click on that. Yes, it's, you can see that read local file tool is listed here. And if you look at the history here, and the MCP inspector sent a request to the MCP server asking to list the tools available, and this is the response it got. And you know that the response is on JSON responses are in JSON RPC2. So return one tool, read local file, and this is the description we have given. So now what we need to do is, so let's select the tool. Okay, so now you can see that, see, we can now, the MCP inspector providing the facility to invoke the service or invoke the tool or call the tool and see or because this is a testing and debugging tool, right? So this is here we can test it and see whether it is working. So this is the same way the AI is going to use our tool. So now we can provide a path and we can run the tool and we can try it out whether this MCP server can use the local file tool to read the file in our local file system. So now before testing this, I need to give a quick warning about this. So since this is this we are just testing and trying to understand, I'm not going to put any security around this. But in a real world case, so you should never allow a blanket rule allowing to access the local file system without any restriction. So if you are creating MCP servers allowing to access the local file system, you definitely need to use permission only to allow certain files or directories to be accessed. So that's later we will discuss the security around the MCP server and what sort of security we can introduce. But for the time being, I'm not going to clutter all those information here. So we will focus on how to successfully implement a tool and the concepts around it. So let's see how we can test this now. We need to provide the path here and we need to see whether this can read the file. So let's try it out. Okay, okay, I think I have a file. Okay, so this is my desktop, and in the desktop I have a file called test.json. And okay, let me open a terminal here. Right, so this is a terminal, and if I list what is here, test.json, and I'll say let's see what is inside. It is just a very simple JSON file which has a message called hello world, and let's see whether our MCP server can read this file. So I'll copy this path. We'll come to our MCP inspector and test.json. So this is what we need to give as the path. Let's run this and see whether it can display the contents of our file, because based on our implementation, the MCP, the tool should read this file and return the content as a string. So we should be able to see the contents of the file here. So let's run this. Yep, it's, see that you can see it's a tool result success, and this is the content of the file. So it's, that is how we can test it. So that's easy, right? So That's the bare minimum first step. Now we successfully completed the first step of introducing a tool with the bare minimum of coding. And now, since it is successful, now we can go and discuss the second step of enhancing the tool. Now, before going to that, I need to again quickly take you to the documentation of the model context protocol. If you click the tools, right, so the most important thing, one very important point with these primitives implementation is the user interaction model. So according to the user interaction model definition, a tool is invoked or a tool is called by the AI model means the LLM. All right, so that means when that means we need to give proper information when we return the response of a tool call. So what sort of proper information we need to provide when we return the response of a tool? All right, so let's quickly look at this tool section of the specification, and let's go to this section, call in the tool. So when you go to the call in the tool, so this is basically the request format and this is the response format. And there is something called, okay, these results content type text and is error false. So that this is a very important parameter, because this is the response parameter that is used by the AI model to understand whether the tool call is successful or not. So if this is default false, so that means it will all the response will always assume there is no error. So that means the AI model will think, okay, the tool call is successful. But if we want to do some error handling, and if we want to return a response to the AI model saying that, okay, so something went wrong in the tool calling, and it was an error due to, so for example, let's say a non-existing file. So then when we return that proper error information, uh, the AI model can self-correct it. So actually, when AI model get a response from a MCP server, there are two types of errors. So the protocol level errors and the business logic level errors, right? So when we take the protocol level errors, it's very unlikely. When the protocol level errors happens, it's unlikely the AI model can self correct it, because it's something wrong fundamentally in the infrastructure. But when something wrong, and during the real execution or the business logic or something, and when we handle that error and when we return a proper error message to the AI model, so then the AI model can attempt to self correct it. Like, for example, in our case, if the AI model tries provide a file name which doesn't exist in the system, and if we say that, oh, this file doesn't exist, and there is an error during the execution because the file doesn't exist, then the AI model can retry and self correct it, right? So that's the most important information. So now, in order to provide that more useful information to the AI model, we need to change the return type of our tooling method response. Because, okay, I'll take you again quickly to this. And if you look at this, see that at the moment we are just returning a string, so which is not really suitable. Or you may decide to introduce a domain model, and you may return a domain model object. But whatever the object that we return, So we need to provide proper information to the AI model. So now what we can actually do is the MCP schema provides the Java MCP schema, or the Java SDK for the model context protocol provides a class call tool result. So we can actually return a call tool result object. Now if I say that, okay, call tool result, okay, I'll change into that, and then I'll for the time being I'll keep it. Okay, so what I will do is, okay, I'll say string contents equals null, and I would say this is contents. uh, I will say again, I'd say contents equals this, and also I'll say boolean is error false, and if there is an error here, I'll say is error true. And now what I need to do is, now I need to return a call tool result object. How we can return a call tool result object? It is we can't just use the new operator and return. There is a build. So what we can do is we can use the build of this. So I'll say return this one dot builder. So not the output is error, and then I'll say dot uh, add content. Yes, so add content, and this is how we are going to return call tool result object. So now let's save this, save all, and now you can rebuild it and try it again. So this way, now this model is better than just returning a string object or returning a domain object, because using this model we will be able to properly return either our situation is a successful situation or a failure situation. So this way the model can make proper decisions and attempt to self correct. So that's the let's end this session, and so if we can try this out, and let's quickly build this, and we'll try this out. The build is successful. We start the inspect. Okay, the inspector started. Let's connect. Okay, connected. Go to tools, list tools, and this one. Run tool, and it gives proper information now, right? So that's basically about how we can implement a tool. Okay, now let's quickly look at implementing resources and prompts, and that will be much more faster. I'll quickly take you through the implementation of a resource and a prompt. Okay, now what we need to do is, now let's see how we can implement a resource. So again, if I quickly take you to what a resource is basically a static contents that we return using a resource. We return static contents. Why we need to return static contents as a resource? Because resources are often used to enhance the context that we provide to the AI model. So that is, I'll take a quick example. Let's say that we are building a chat application for a airline ticket booking system, and let's say a customer log into the system, and customer start a chat session and asking, hey, can I cancel my booking? And then in order for the AI to action on that, AI need to know the ticket cancellation policy. So then now what we can do is we can put the cancellation policy inside the file within the MCP server itself. And what we can do is using the resource primitive, we can return the cancellation policy. So that is again reading a file, but the contents of the file is always static, right? So let's now try to implement this. So let's say, okay, um let's put a new package under this, sorry, not under there, we'll put under AI a new package called resources, and under this new class, I'll say, mm, uh, I'll put an example saying, okay, greetings resource, because I want to get a very simple example, and I want to, without taking too long, I want to explain this and finish this with a very simple example. Okay, greetings resource, we'll add this. So as usual, we need to first tag this as a component or a service. So now, because that's the MCP Spring Boot framework level requirements. And then what we need to do is now we need to implement a method, public string greeting, and something like this. So very simple, because I want to show the example of returning the static content. So that's the idea behind the resources. So then what we need to do is now, just like we tag earlier when we implement the tool, the tooling method we tag with the tool annotation. Now here we need to tag this with at mcp resource, and name, and we can provide a name and a description like this. Very simple, right? And we can try this out now. Just like this, in terms of the Spring Boot framework wise requirements, we completed our first stage. So that means we have now successfully plug in the resource into the framework. So if we try this, this will work. But since it is taking time, I want to do the enhancement and try it out, right? So then the next enhancement we did with the tooling implementation is the return type. So we changed the return type to a call tool result. So look at the naming convention. A tool is called by the AI model according to the interaction model. So that is why we said, okay, call tool result. So now when we take a resource, a resource is read, but when if you look at the model context protocol definition, the user interaction model, uh, a resource is not meant to be you directly called by the AI model. It is actually to be used by the host application. It is actually to be the resource actually to be read by the host application. Once the host application read the resource, the content of that resource can be used by the host application to enhance the context when invoking the AI model. So that's the idea behind the behind implementing the resource. So therefore, now what we need to change the return type of this method. So just like tool is called, a resource is read, so that means read resource result. So that's the idea behind the return type, right? Okay, we now we'll see how we can return the read resource result object. So we can return the read resource result object with this way: new read resource read resource result, like this. And so it needs to be a list. So what we can do is we can say list dot off, you'd say. And then so we need to create, since we are returning textual information, we need to create new text resource contents. Resource text resource contents. So that is basically, we need to take it from here. Text resource content. So this is the class we need to use. So we take this new text resource contents, and list of new text resource contents, and this is the content. And we need to provide the MIME type, so that is the text. And then okay, so the first one is the URI. See that the first one should be the URI, not the actual content. So I'll say the URI is I'll say greetings colon hello, and the MIME type is this, and this is the content of that, right? So I'll quickly import this class java util list, right? List of, so the first one is this, and the second one is this, and the last parameter is this. So this is basically what we need to do. So that is the URI. So the first in the text resource contents, the first parameter we need to pass is the URI. So because the URI is the unique identifier for the resource within this particular MCP server. So you can give this is actually a custom URI. If you want to look at more details what a URI is, so there is a RFC documentation, and the model context protocol links that RFC documentation there, so you can read the details. So this is a custom URI. A URI need not to be the real locator, but so I have given a custom URI here, and the type is text. The MIME type is the plain text, and this is the static information that I want to return. So that is the resource implementation. Let's quickly try this out. Terminal and build. Okay, now the build failed. Let's quickly see what's the issue. So let's copy this, and I'll take you to the, okay, so this is the failure. So let's have a quick look at the failure. Okay, so let's go here. So if you scroll to the bottom, so it says URI must not be empty. According to the model context protocol definition, schema definition, something is wrong. So that's why it is failing. So let's fix it. So okay, so let's go here. So the problem here is this: actually when you define MCP resource, we need to provide the URI, because as I told you earlier, URI is the unique locator for the resource within our MCP server. So therefore this need to have something called URI first. Yeah, so greetings, hello. So that is what we were missing. So now let's save it again. Let's build it again. Okay, the build is successful now, and let's start the inspector. Okay, the inspector started, and it's connected now. Yeah. So resources, I'll say list resources, and you should see the greetings, and see the when you click the greeting. So this is what you get. The URI is this, and the MIME type, and this is the content of that. So that is all good. So if you closely look at this, there is actually resource and resource template. What is this resource template? If we quickly look at, if you provide a parameter during resource implementation, then it will be a resource template. So let's quickly try that out now. I'll close this again, and let's say I want to put a parameter here, string name. I want to do like this, and I would say hello name. Let's say name. I would say this. I'd say this. So that is, I just change. If you want to look into the details of what this URI, as I told you, so you can look into the definition of the RFC documentation on that. So I'll save this, and let's try it again quickly. Okay, the build is successful, and we successfully started the inspector and connected. And now you can see that if you look at the resources, now if we now click the list resource, it should be empty now, because see that list resource response is empty. Why? Because since we have introduced the parameter into our resource method, now it is not just a resource, it's a resource template. It has become a resource template. So it is now available under list, under resource template. So if I click the list templates, now you can see that there is a greetings, and if we click here, it says enter the name. So if I enter my name, and if I say this one, see that greeting, hello Thushan, and hello Thushan, and this the text content comes. So that is all about the resources. Okay, let's now quickly close this, and let's quickly implement our final primitive, a prompt, which is much more easier, and we can without taking much time, right? So then I'll close this, and I'll go to this AI, and I'll put another package saying prompts. So under this, I will put another class as usual. I'll say build greetings prompt, right? And then so as usual, so we will tag this as a component, and then once we tag this as a component, So then we need to introduce a method. I'll say public. Okay, so this is build, and so this we need to introduce a public method. Once we introduce the public method as usual, so then we need to say MCP prompt. So that is what we need to do. So the first one, we put the tool annotation. The second one, we put the MCP resource annotation, and this one we need to put the MCP prompt annotation, and we need to give a name. Yeah, so this is what we need to so I'll change this to build prompt, build prompt string. Yeah, so then I would say um, build name. I'll put a I want to implement this as another method, so I'll put this create method. Okay, so this one. So now I want to say return this method also, right? And we'll say this is just the idea. So and event. So this is basically what you mean by a prompt. And then again, as we discussed in the previous sessions, without returning a string, what we can do, what we can actually do is we can return, because according to the interaction model, a prompt is to be a prompt is get. So that is again, a prompt is not directly to be used by the AI model, but actually according to the interaction model, a prompt is to be used by the real user uh, in order to interact with the AI model. So therefore, again, the prompt is for the user to get. So that means the return type should be get prompt result. So that should be the return type of that return type of the prompt method. So we saw earlier during the tool call tool result, during the resource read resource results, and now in the prompt get prompt result. So now let's see how prompt. I'll change this to a string prompt, so it get that. And then so this is how uh, we need to return it. Okay, so I'll copy paste what we need to do. How we build the get prompt result. So we use the new operator get prompt results, and so description is build greetings prompt, and then we need to provide the real greetings. We need to provide the real prompt, so using the list of new prompt message, and we need to give the actual prompt content, and we need to specify the role of this particular prompt. The role means who is going to use this prompt. So that means we told that okay, basically these prompts are to be used by the user. So the real use case of this prompt is actually the user. So that's why we said user. So there are other roles. So you can look into more details in the documentation. Again, if you look at the model context protocol documentation, you can see all these details. So basically this is how we implement a prompt. And now if we save all these, and let's one last time, let's build it and try it. Okay, now the we build it successfully, and then we connect the MCP inspector successfully. And now, if we look at the resources, so we have we should have one resource, one prompt, and one tool. And a resource we implemented as a template, greetings, and if you say your name, so it comes here, so that's good. And then prompt, if we say list prompt, and build greetings prompt is there, and see that all the parameters exit, enter name, so I would say Thushan, and event name, birthday, and get prompt, and see that it gives us the prompt. So build greetings prompt, and this is the content of that, and see that this is the actual prompt. You are a senior event planner, and blah blah blah. So that comes, and then if we go to the tools, and if we say list tools, read local file, so we have that one. Now we have all the three primitives successfully implemented and tested. So this is all about how we can implement these three primitives, and I hope you understand what we discussed so far, and you successfully followed what we discussed so far. Again, as the last one more time, I highly encourage you to refer to the model context protocol definition documentation, which should be always your handbook in implementing these MCP servers or the MCP clients. So that is very important. And if you have anything, please comment on the video. We will have a proper discussion on those queries, comments, anything. Thank you for watching. And this is the end of the three-part series of building MCP server using Java and Spring Boot. Thank you.